Hello everyone, in this video I'm going to show you how to complete the exact same two dihybrid problems that we did in the previous video, but using the shorter version of how we can work out a dihybrid, which is using two separate smaller monohybrid boxes instead of one larger up to 16 box dihybrid square. So you can see I've already taken the time to highlight a lot of the portions of the problem that we generally need to do first before we try to answer the problem. I've already up here given some symbolism. I highlighted in green a woman heterozygous for black hair and being tall, and I wrote her genotype over here. She's going to be crossed with a man who is homozygous for black hair and being short. This is his genotype right here. And the problem wants us to answer, what is the probability they will have a child who has black hair and will also be short? So what that means is, down here on the probability line, we're looking for an offspring that will at least be heterozygous for black hair, and to be short, again, we're going to need two lowercase t. So that's what we're looking for. So what we're going to do now is we're just going to look at the chances of having a child with black hair by just crossing that first gene between the two parents, and then we'll look at height separately in another monohybrid square. So down below on the left, I'm going to first fill out my first Punnett square for the mother being heterozygous for black hair and the father being homozygous dominant for black hair. I'm going to fill in this Punnett square. Again, keep our dominant alleles in front always. And when I'm done, every time this couple has a child, they pretty much are going to have a 100% chance of having a child with black hair. Now, two of the four genotype options will be homozygous dominant, while two of the four will be heterozygous, you can see here. Well, let's make a note below that pretty much they are going to have a 4 chance of producing a child with black hair, or we can just make that equal to 1 for 100%. That's what they're going to have every time they have a child. Also, separately, off to the right, what I can do is, of the four genotypes, two of them will be homozygous dominant, and two of them are going to be heterozygous. Now we need to figure out what the odds of them producing a child is going to be short. So in the second Punnett square on the right, I'm going to write the mother's genotype up top. Again, I can write her on the top or on the left, doesn't matter. Father I'll place on the left, homozygous recessive for being short. I'm going to fill in my Punnett square here. See what all the offspring possibilities could be. And of the four possibilities, now I have actually two, again, unique genotypes. Two of them, let me go back right there and get rid of that. Two of them will be homozygous recessive for being short, but then two of them will be heterozygous for being tall. So of the four options now, what we have is two of the four will be short, which is what we're looking for in the offspring, homozygous recessive, or a 1/2 chance of producing that type of offspring. I'll also write now over here to the left of that Punnett square that I have of the four, two options of the children being heterozygous, and two being homozygous recessive. That's going to help us with our ratios up top in a moment. But now to finalize our answer, what the problem wants to know, the probability of producing a child with black hair and who's short, I'm going to take the odds of producing a child with black hair right here. I'm going to write number 1. And I'm going to multiply that by the chances they're going to also produce a child who is short, which is 1/2. So 1 times 1/2 is obviously 1/2. Or 50%. And that's the exact same answer that we got in the long style version of performing this problem. Now for the ratios, we can't see the full genotypic ratio at once like we did in the larger Punnett square. So I did this to help me with that. So every time they have a child, they have two of the four possibilities of producing children who are homozygous dominant for black hair. So I'm going to take those two big B options, and I'm going to multiply that by the options for the two possibilities for height. So I'll just draw a line here. 2 times 2 is 4. So that means they have, theoretically, a ratio beginning with 4 possibilities for big B, big T, little t. Or the two big B's could end up with the two little t's. So that is going to be now what? 4 big B, little t, little t. But we're not done. Now we got to focus on the heterozygous B variety, and we do the exact same thing of multiplying the possibilities. So again, 2 times 2 is 4. So we're going to get 4 options that are heterozygous for B and heterozygous for T. And then finally, 4 options, running out of space here, that'll be big B, and little t, little t. If you reduce that, it would be a 1 to 1 to 1 to 1 ratio, just like we also got in the long version of performing this dihybrid cross. So the ratio is the same, even though I have it in the expanded version of 4 to 4 to 4 to 4. If we reduce it, again, it is 1 to 1 to 1 to 1. Now for phenotypic ratio, all right, if I look at all these options here on this line for genotypes, I'm going to have, let's see here, a total of this genotype gives me black and tall, as well as this. So if I look at my numbers, I'm going to have a total of 8 individuals who would be black and tall, colon, finishing out, I'll choose a different color here. This is black and short. This is black and short. I got 4 of each option. So once again, then I can then rate that as a total of 8 black and short. And if I reduce that, it is a 1 black and tall to 1 black and short ratio, the exact same thing that I got for the long style of this problem. All right, let's do the second problem the exact same way as we just did here. I can actually get it to drag up. Here we go. Again, I've taken the time to highlight all the information that we need to know here. I've already given myself my key for over here. We can see that to be round peas, at least 1 big R. To be wrinkled peas, you have to be homozygous recessive. Yellow peas, you need to at least have 1 dominant Y. To be green, you have to be homozygous recessive. I have my parental genotypes based on the problem. In orange, a homozygous round and yellow pea plant, that is this one here, is crossed with a pea plant that is heterozygous for shape, which means big R, little r, and homozygous recessive for color, which is 2 little y. So that's this one over here that I have highlighted in green. And the problem wants to know what is the probability they will produce offspring with round and yellow peas. And that would be this genotype down here that I'm circling right now. So we're looking for individuals who at least have 1 big R and 1 big Y in this instance. So once again, what we're going to do is we're going to do the monohybrid style way, where we're going to cross the individual genes first and then relate them together later. So starting with shape, on the bottom left monohybrid, I'm going to write big R up top. Make that a little bit better. There we go. And I'm going to write the other parent as heterozygous on the left. Let's work this out. Big R, little r, 2 big R's, big R, little r. The other parents the other gene for the 2 parents. One parent is homozygous dominant, the other is homozygous recessive. We fill out this Punnett square. And now we can go through and interpret. Starting with the shape for the peas. All right, every single pea is going to be round. 2 of the 4 will be homozygous dominant. 2 of the 4 will be heterozygous, all right, for also the dominant trait. So once again, what that means is chances of these 2 producing a round pea child is literally going to be 4 of the 4 possibilities, or we're just going to make that equal to 1 or 100%. Genotypically, they are going to produce a possibility of 2 individuals that are homozygous dominant and 2 that are heterozygous. Now for the color, let's take a look over here for color now. They are going to have 4 individuals who are all heterozygous for color. So they're all going to be yellow. So every time this couple has a child, that child will be yellow regardless. So make a note, 4 out of 4, which is equal to 1. Again, this is the number for the chance of them having a child who is yellow. This over here was the chance of them having a child who's round. So to finish out our probability, we're simply going to go 1 chance of them producing a round P, multiply that by the chances they'll produce a child who is yellow, and that gives us a 1 or 100% chance that they're going to be able to produce a child that is over here that we had written our key, round and yellow. And that's the same answer we got in the long style as well. So now let's finish up our possible genotypic and phenotypic ratios. Let me finish by making a note over here that all 4 possibilities that this couple can produce will be heterozygous for yellow. And now once again, we do our multiplication. So the 2 big R options multiplied to the 4 big Y little y options. So 2 times 4 is 8. So we're going to have a possibility of 8 individuals who would be big R, big Y, little y. And then multiply the other option for shape, 2 big R, little r, to 4 big Y, little y. So there again is then going to be 8 individuals who could also be heterozygous for shape and heterozygous for color. So our genotypic ratio here, the way we just figured out, is 8 big R, big Y, little y to 8 big R, big Y, little y. If I reduce that, it is a 1-to-1 ratio, the exact same one we got in the long style. Now, to finish that out for phenotypic ratio, of all the options that we wrote down for genotypic ratio, really only 2. This one here will produce round and yellow offspring. This one over here will also produce round and yellow offspring. So between those 2 options, what we end up with is 16 individuals who will be round and yellow to 0 other options. There is no other possibility. Reduce that, again, we can make that just a 1 round and yellow to 0 other options, which again is what we got in the long style. So it tends to be a little less busy when you do the 2 separate monohybrid crosses, but as long as you're careful, especially when you're trying to do ratios, you're going to have to do when I'm circling down here to figure that out, you can get to the exact same answers that you do with the long style. So again, in the future, for both quizzes and worksheets, you can choose either the long style or the short style we just did here. As long as you're showing the work and proving to us how you can get your particular answers to a problem, that will be sufficient. Hopefully this clears things up. Thank you very much.